I think most do. Jim Simpson, Climate Realist of Five Doc. Thanks for those that haven't been around before. It's lovely to meet you. It's also a pleasure to welcome back our good friend Howard Brady. He's been here before. He's up on our YouTube channel and spoken about climate-related matters previously. Joining us tonight to talk about problems in climate science, a destructive trail left by climate models. We've read lots about it. Howard's had more than a little experience in his past academic life. And without further ado, I'd like to welcome Howard to our ranks.
Thanks, Jim.
Floor is yours, Howard.
Before I start, I'd like to congratulate Jim for all the work he's done over the years. It's just amazing. I mean, there's a lot of articles I'd never even know existed, except that Jim has found them and put them up on his website. So it's lovely to check Jim's website every couple of days to see what emails I've got, because trying to chase literature all around the world isn't very easy, and it's amazing considering Jim's not a real background as a scientist is what you've done, and I'd like to congratulate you, Jim, and thank you very much.
I might add, Howard has brought along with him his publication called Mirrors and Mazes. It's available for those that might care to purchase it. And not only that, our good friend Jeff Grimshaw has also his publication called Trigger Warning. For those that might be interested, that's available as well. Thank you.
I think that the COVID fiasco, or whatever you want to call it, showed us all just how bad models can be. And I think the public has become very aware of the limitations of models. We saw people predicting hundreds of thousands of deaths or the opposite, etc. And people realise that models aren't everything that they're made up to be. And yet in climate science, it's been driven by models ever since the first models were developed by Sakura Manabe in the 1960s. And yet there's been a trail. They can be helpful, but they've also left a trail of disaster, of false argument, of oversimplistic argument. And today I want to address that. My first exposure to model land was when my wife and I retired to a very peaceful place called Culburra Beach. And the Shoalhaven Council, in a fit of enthusiasm, decided they would start applying the IPCC sea level predictions to properties in the Shoalhaven district. To do this, they got the, believe it or not, the Snowy Mountains Authority's engineering department, who are hardly experts in climate science, and they then produced all these lovely diagrams. So they then started to put lines on people's houses as to where the sea would be in 2025, 2050 and 2100. And to do that, they used a thing called the Brun Model. So this is my first confrontation with a bloody model. Peter Brun was an American environmental scientist, and he came up with the idea in 1954 that when the sea level went up, the beach profile would stay the same. It would simply migrate landward, because every beach has got an angle depending on the grain size of the sand. And he came up with the mathematics that basically if sea level went up a metre, there'd be 100 metres of retreat. But if we had a bay where it was shallower, it wouldn't be quite as much. But it's all very complicated mathematically. And so when the Snowy Mountains Authority came up with it, they then produced all this lovely mathematical stuff of where the sea would be in these different years. And when you see all these figures everywhere, and people presume because it's mathematics, it's correct. Now, any of you who know the South Coast, I put up a couple of the streets that were involved just out of interest. One was Marine Parade at Culburra Beach. Another one was Key Street in Killala Beach. Another one was Elizabeth Drive at on Collingwood Beach, near Vincentia. Another one, say, Mitchell Parade at Mollymook. And now there are only some of them. But they are the ones, and it's suddenly, it's going to happen here. People who never knew anything about climate science are suddenly confronted with the fact that the sea's going to inundate their house, and their house values plummet. So the National Bank and the other banks start to devalue houses and drop down the mortgages on them. One of my friends at Vincentia, his neighbour went bankrupt because he'd mortgaged his house, his business in Sydney. He'd mortgaged the house to help the business, and then the bank made a mess of that. So it was quite a trying time. In Marine Parade, there was a builder who came to me and said, look, Howard, he said, I take a photograph of the beach every year, and I've been here 20 years, and there's now more sand in front of my house than there was 20 years ago. But he said, when I went to the council, they told me, you're just an amateur, you don't know what you're talking about.
Either do they.
Now, that's just a simple schematic of the Brun Wall, but it's a simple migration of the beach. And so the Snowy Mountains Authority start to put these migrations everywhere in the Shoalhaven. I'll show you that in a minute. But here's a good example. This is Kalala Beach. The blue is 25, the orange is 2050, and the purple, whatever it is 2100. You can see there that the main street along Key Road there, 3/4 of the properties have gone by the end of the century. And you can imagine what those diagrams did to house prices in the area. So I thought to myself, well, wait a minute, sea level's supposed to have been going up, we're now in 2008, for a long time, so why can't we check it? And I had a very good friend who was a surveyor at the Shoalhaven Council, and he said, do you know that the government take a photographic run of the whole of the coast every year? I said, no. He said, I can get it for you. So I had a very powerful computer. So I ended up with all of the South Coast beaches, photographs from 1948 when it started to 2008. And I said, well, let's start putting these on top of each other and see what the hell's happened, because there's nothing like, I'm a field geologist, there's nothing like a bit of factual information. Now, when I did that, I could find no evidence the Brun Model was valid. I spoke to a Professor Cooper, who was a South African in charge of the coastal science in North Island, who was a world expert, and he said the Brun Model doesn't work. I spoke to a Professor Stevenson in Dunedin, and he said to me with a lot of New Zealand expletives, how there's not one F beach in New Zealand you can apply the Brun Model to. And anyhow, when I did that, if you look now, you can see, here is Culburra Beach, an area of it in 1948. A lot of sand. Here is Culburra Beach 60 years later. Look at the amount of vegetation. Look how the vegetation had grown. So what was happening was the vegetation in the foredunes was growing, maybe because there's more carbon dioxide in the air, but it was a sand trap. And the beaches were growing seaward. They were supposed to be retreating. And when I gave a speech to the Culburra Progress Association, and one of the council engineers were there, and I explained this, he got up and said, you've got to realise that Dr. Brady's just an amateur. So that was quite a good introduction to the council. But to get away from Culburra Beach, where you could say, oh, well, this is probably due to, civilization and people, this is Kinghorn, which is south of Culburra. There's no one there. And you can see here that the foredune is growing seaward. It's right up to the high tide mark, and it's just thickening all the time. And the reason it can trap so much sand is that the type of vegetation in the soil, you don't put trees. You have to have things like creeping grasses or pig face, things like that, and they are efficient sand traps. So that basically, when I looked at the photographs over those 60 years, these beaches, now it's not the same all over Australia, but the beaches in the Shoalhaven area were growing seaward until there was a storm surge, Then this fortune would be wrecked, and then it would start growing again. Now, the storm surge evidence is very interesting. Here is a photograph of Kalala Beach in 1950 when this developer just couldn't do it today. He just bulldozed the top of the dunes and people put their little fibro shacks on top of the dunes. And, but in 1974 was the worst storm surge in New South Wales in the 20th century. It was quite horrific. It went for 10 days. At the start, the waves were over 6 metres, and then it died, and people thought it was okay. And then near the 10th day, they jumped to 6.8 metres again. The Navy people came over from the base to help with the sandbagging, and you can see here in this photograph here, the Navy people were mainly helping putting sandbags there to protect these old fibro shacks. So they were pretty violent storm surge. Oh, by the way, the greatest storm surge in Australian history happened, does anyone know where? Bathurst Bay, has anyone been there? North Queensland, up near Cape York. In the 1890s, the storm surge was near 14 metres. Pretty well everyone at Bathurst Bay died. 300 people died, a lot of them natives that they'd brought down from the islands to go pearling. Shark bodies were found 40 k's up creeks. There were dolphin bodies on top of cliffs. But over 300 people died. Apparently there's no one there now, but one of my friends was in a yacht who called in there some years ago, and he said there's a little monument there to the people who died. But that was the biggest storm surge Australia's ever seen, and that was in the 1890s. But in 1974, that's the biggest one New South Wales had in the 20th century. At Culburra Beach, for 24 hours at one stage, the wind was parallel to the beach. So the houses that were on the headland that were in line with the beach, one of the builders told me, all the windows were frosted white. They had to be replaced, and the gutters were all the paint was stripped off them. They were gleaming like steel. So it was quite some storm. You can show here, that's the storm surge in 1986. Kalala Beach is improved now, the houses have been upgraded somewhat. This is the one in 2012, I photographed that. And here, I went back in 2021, and you can see everything's still back to normal again. But people don't believe the lines anymore, so all the house prices have gone through the roof, and people don't believe it anymore. Thank God. Now, this idea of beaches being dynamic features is also true in the South Pacific and also in the Indian Ocean. The islands are really on atolls, which are sort of mounds perched over old volcanoes and things. And basically, what's happened is a Professor Kench at Auckland Uni and another man from the United Nations, they've done photographic evidence of these atolls again since 1948. And what happens is that some of the beaches get loose, but on the lagoon side they grow. So that basically of these islands in this area, over 70% of them have grown in the last 70 years. At the same time, well, all these islanders are going to the United Nations meetings and wanting money. But the whole thing is a fraud. It is not true at all. So the South Pacific Islands and the Shoalhaven, they've got something in common. Sea level rise is not critical to the way the beaches move. The dynamics are very, very different. So in the Pacific Islands, there's lots of land on the ocean shorelands, but again on the lagoonal side of the islands. Now the second problem, so that's the first problem I've seen, and you can see that the whole thing didn't make sense. After I looked at the Shoalhaven area, I thought I've got to go a bit wider than this and look at sea level in a wider perspective. Because if you look at the IPCC documents now, they say that the sea level is accelerating. But if you go through the IPCC reports in 1990, 1994, 97, 2001, all of those committees looked at sea level evidence for the whole of the century. They couldn't find any acceleration at all. They admitted it. They said there's been some rise at sea level, maybe 13, 14 centimetres, but it's been steady. There's been no acceleration at all. Because if sea level doesn't accelerate, we can't have a catastrophic situation at the end of this century at all. Now, if you ever want to look at tidal data, the place to go to is this National Oceanographic Centre at Liverpool in England. Every tide gauge around the world that is worth its salt is recorded there. It's got a number, so if you find the number for, say, New York or Hong Kong or anywhere, you then type in the number and it will show you the history of that whole tide gauge ever since it started, because some go back a couple of hundred years, some haven't been around very long at all. So you can see here that some of the database that's at Liverpool. So that's where you go if you want to get good tide gauge data. When you do, if you look at over on the left here, they are the New Zealand tide gauge. It's about you've got Auckland, Christchurch, Dunedin, you name it. You can see that the sea level is going up, but there's no acceleration means bending upwards. There's none of that at all. That's Honolulu. This is the Battery in New York, and that's Fort Denison down there. So very little change, but it's linear. It is not accelerating. But the trouble happened that in around 92, NASA put up a satellite system to start looking at sea level rise. It's up around 1,300 k up. And by the IPCC meeting in 2007, they had enough data to start looking at it. When they did, all of these scientists that wanted to find acceleration said, hey, wow, sea level's now going up at 33 centimetres a century. The tide gauges say 13, 15 centimetres. We've got acceleration. But wait a minute, two different methods can't be joined together, because if you look at the satellite data in its own, as an inherent database on its own right, it's not accelerating either. It's just different. So there was a Professor Houston, US Army Corps professor, and he said, wait a minute, there's errors in the satellite system. They're giving you relative data, but it's not giving you absolute numbers. And then in 2012, NASA itself admitted there were problems with their system, that it's not absolute numbers at all. And if you go to the latest data, which is being kept at the University of Colorado, you'll see them still talking about acceleration, but it's going up at the same rate as it did 20 years ago. So the weird thing about sea level is you've got the tide gauge data, you've then got this mess here of the IPCC now mixing satellite data and tide gauge data, and then you've got some extreme climate centres like the Potsdam Institute for Climate Impacts that advises Angela Merkel, and was also, of all things, advising the Catholic Pope, of all things. And they've had very extreme views of sea level rise, maybe going up 2 or 3 metres in the century. So that's the mess at the moment of sea level. So, but if there's no acceleration of sea level, dramatic sea level rise this century, that's impossible. So there's no need to panic. Now, the third problem, we go to another model now. Everyone you hear talking about it says, look, if CO2 goes up, which is carbon dioxide, temperature goes up. And that's the driving force at the moment through a lot of climate science. And I'll get into some of the what we call the Equilibrium Climate Sensitivity Index later, but that's driving things. But I'm an historical geologist, and when you look at history, that doesn't make sense at all. Over the last 500 million years, we've had ice ages when the carbon dioxide levels have been 10 to 14 times today. That was way back in the Ordovician. Back in the Permian, we had a cold, we had low. But then in the Jurassic, we again had carbon dioxide levels 5 times today, and we had another ice age. So carbon dioxide levels can't stop ice ages. We're in a much, much bigger system, and carbon dioxide isn't driving things. But then if we go to a smaller time frame, now the graphs on the left, believe it or not, come from the British Hadley Centre, which is a centre of climate science in Britain, and they show that in England, over the last 160, since 1860, there's been 3 warming pulses. When you look at those pulses, each one's the same, about 0.15 Celsius per decade, the same, and yet in each of those times the carbon dioxide levels have been much higher each time. If carbon dioxide is getting higher, surely this one here should be a lot steeper. It's not. This is a graph of CO2 going up. So that basically there's no evidence even in the last 160 years that carbon dioxide's been the main driver of warming. And if you look here, 1860 to 1880, carbon dioxide going up at only 2 parts per million per decade. Come back here to recently, it's going up at 20 parts per million per decade, but the rates are around the same. It doesn't make sense. If CO2 is driving things, we should be getting very, very different gradients. And if you look at it a long time, again, that's another graph here of how CO2 is varied over historic times. And then over the last 140 million years, we've been getting this drop in carbon dioxide. So there's various people now saying, well, look, it's about time it went back up, because if it goes too low, it's going to be a threat. Now, the fourth problem now, we get into a very interesting models here, because you've all heard about the Netherlands with their 5 million cows, or New Zealand with its 10 million cows and 26 million sheep. And people want to put tax on methane and all that. And it's true that if you go to a laboratory and you compare carbon dioxide to methane, methane's much more powerful. And in the laboratory, if you look at nitrous oxide and you compare one molecule, again, it's quite powerful. But in reality, the concentrations are very, very different. And in reality, they're all competing with water vapour, which is 60 to 80% of the greenhouse effect. Now, if you want, it's very hard to come up with some simple metaphor or to explain all this, but imagine a smorgasbord at a very, very posh restaurant. The smorgasbord table is 100 metres long. And of all the beautiful foods there, and there's thousands, you can only have the striped prawns from the Gulf of Carpentaria. Now, methane's like that. There's only, at around, 7.8 microns or whatever it is, it can absorb at that level, but so can water vapour. So you've got one methane molecule trying to grab those prawns, and at the same time you've got 3,000 rugby players, call them the water vapour molecules, also after those same prawns. Methane can't win. 3,000 to 1, it's pretty not good odds. And nitrous oxide, which is around 8 microns, where its main absorption band, it's got even a worse problem. You're talking about thousands of times. And then when you want to get wrapped up about people talking about methane, if we can imagine every person in Sydney being a molecule in the atmosphere, well, of the 4 million people here, there'd be 4 methane molecules. 4 people in the whole of Sydney would represent the methane concentration in the atmosphere. How crazy is that? The whole thing's gone bananas.
You know, they've hyped up the methane too. It used to be 20-something worse than CO2. Now they've...
No, it's making it 80 times.
Now it's 84.
Yeah, I know, but
They've hyped it up.
But that's all in the lab.
Yeah.
And the strange thing is, the science of that was done by an Irish physicist in the 1850s. And he worked it all out, doing them all separately. But then he said in nature, he said if we didn't have water vapour in the air, we'd all freeze and there'd be little life on the earth. If you look at this diagram here, carbon dioxide is absorbing between 14 and 16 microns, but there's water vapour competing with it. Look at that. It's not fair. And if, sorry, I've mentioned that. But here, again, this is methane, and there's your water vapour again. So look at all that water vapour competing with methane, can't do it. And the nitrous oxide is just to the side, the same thing. So the science of this is, it's got mad, because it's almost as if water vapour doesn't exist. And yet most of the greenhouse effect is in the lower 4,000 metres of the atmosphere. And if you went to New Zealand, that figure I gave you, 3,000 molecules versus 1, that's a temperature of 15 degrees, relative humidity about 50%. And New Zealand would be around that. This is another diagram from Professor Happer, who has been a very good friend to me over the years. He's a world famous physicist out of Princeton. And they've made this diagram, and they showed the difference. This gap is the effect of carbon dioxide, but then down here, once carbon dioxide's at 400 parts per million, if you double it to 800, there's hardly any change. Because it's done as much as it can do. It's exhausted, it can't do any more. So that if you keep doubling it, the effect is peanuts. And that's the same also with methane. The next problem in the models is, anyone who's an historical geologist knows there's a lot of there's a lot of cycles in climate. I'm not talking about just ice ages that happen every 100,000 years or variations and all that type of, but even in a shorter term, there's all these cycles. And if you look at sunspot cycles, we may not even understand them, but in the 1600s, we had a period of no sunspots and it was cold. Between 1800 and 1825, we had the same thing, it was cold again. So for some reason or other, there's some link between a lack of sunspots in the sun and cold weather. So the question is, if our sunspot numbers drop this century, could we get another cold snap again? Why not? There are scientists saying that, but no one in the IPCC wants to know it, because all the IPCC reports are based on human beings on Earth. There's no reference to the sun, there's no reference to the planets, there's no reference to the whole of the cosmos. Look at these cycles here. On the left here, that's a north-south variation in temperatures in the Atlantic Ocean. It's a sort of a 60-year cycle. That's been going on for centuries. Over here, this is another, again, it's a 60-year cycle, periods of 20 to 30 on each side, which is a east-west cycle in the Pacific Ocean, varying temperatures. Down here, we've got the El Nino, La Nina oscillations. They're not that predictable. But over here, we've got a mass of the solar system with the planets, and that's also oscillating. But none of the climate models used by the IPCC ever take any of these things into account. The computer models aren't looking at anything historical at all. They're simply looking at greenhouse gases, and then they're making a mess of them at the same time. This is a famous graph that was done by a Japanese physicist who was famous with his work on the ionosphere, and he was a professor at Alaska. And he was looking at these 60-year cycles. He said, really, we've been oscillating since the 1850s. Why can't we keep oscillating? And yet the IPCC is doing that. He said, if we follow historical cycles, then our graph's going to be very, very different. So the next problem is, and I'm sure you're sick of the word unprecedented. Now, are these floods at the moment in New South Wales unprecedented? Is the rainfall unprecedented? Are the droughts are the bushfires unprecedented? You can't have unprecedented over 20 years. You've got to take unprecedented over a couple of 100 years, because nature and climate are very, very different. For example, in the 30s, there was a scientist called Callender who predicted that carbon dioxide was warming the world. But then, after the Second World War, 1960, 61, 62 were some of the coldest winters in England since the early 1700s. And that was near his death, so we don't know what the hell he was thinking then. But again, what's unprecedented? What time frame can you use for unprecedented? surely you need at least a couple of 100 years. And if you look at the warming today, the warming 5,000 to 8,000 years ago was just as much. All these people had a meeting at Glasgow, right? And if they went to the hills behind Glasgow 8,000 years ago, they were covered in forests, they were that warm. Well, wait a minute. Was that a dramatic time? Was that a catastrophe for the world? It wasn't. Now, if you take this period 5 to 8, I got interested in this because as I walked around the Shoalhaven district, I realised that this warm period 5,000 to 8,000 years ago was very clearly, you could see that in the history of the Shoalhaven district. You can also see it, there's a swamp, I don't know if any of you know, at Burrawang, the Wingecarribee swamp. And I was the first person to make a depth profile of that swamp. And then we got the ANU to carbon date that swamp. It was about 30 metres of peat in some places. Then they put a dam there, and then of course eventually it got wrecked because it wasn't, the water board mishandled the whole dam. But that was a warm period about 6,000 years ago. And if you look at the cliffs around Culburra and you look at the barnacles on the cliffs, because sea level is going down, the barnacles can be carbon dated. So if you've got barnacles high up in a cliff, the sea had to be higher for them to be there. And if you graph them, one graph here on the left, that's done by Dr. Sloss at Wollongong Uni. This one here is done by a close friend of mine, Professor Peter Flood, who was Pro Vice Chancellor at New England. But you can see that sea level around 6,000 years ago gradually dropped down to about 1,000. So we've had high sea levels, we had that warm period, 8,000 years ago, and then gradually sea level dropped. At that time, the Greenland ice sheet was smaller than today. Now they're worried about the Greenland ice sheet melting. It was much smaller 8,000 years ago. If you look at these diagrams, this is a sea platform 6,000 years ago at the mouth of the Crookhaven River near Culburra Beach. Now, if you go near that, you can see behind it the middens with all the shells where the natives were, eating their shells there, and they're enjoying a much higher sea level. On the left, this is a wave notch at Red Point. Now, if you go to Kalala Beach and walk a bit towards Point Perpendicular, you'll come to that point. This wave notch was carved in the beach again when sea levels are much higher 6,000 years ago. So we've had a very warm period after the last ice age, which was warmer than today. And at that time also, these glaciers in Antarctica that they were worried about, like Pine Island, etc., they retreated then also. And some of my scientists I knew at Cambridge, they were the ones who checked that out. Then we get to this other model. Every time there's a storm, we're told how bad they are. But the whole thing's around the wrong way. When we have an ice age, the polar ice cap is bigger, the colder air gets to Australia, Central Australia gets more rain, storms are worse. So during the last ice age, Central Australia, Western New South Wales, the storms were worse. Now that it's getting warmer, the frequency of the storms is dropping. It's all around the wrong way. Here are graphs. This is tropical wind energy over the last 40, 50 years. Look at this, it doesn't make sense. This is US tornadoes, that's wind energy. US hurricanes and Australian cyclones. There's no trend of them getting worse at all. And yet every time that something happens, we get some idiot saying it's unprecedented and they're getting worse. Now this, I suppose as an Antarctic scientist, I've got a little bit of maths behind me. If sea level changes, the ocean's 70% of the world. You need a lot of water to change sea level. Now to raise sea level 1 metre, you need 360,000 cubic kilometres of ice, and that'll only give you 1 metre of sea level rise. So if you have an iceberg from Sydney to Perth that's 100 k's wide and 1 k deep, that'll give you 1 metre. Imagine an iceberg from Sydney to Perth. I mean, and yet someone will tell you that Greenland's losing 400 gigatons of ice a year. And you say, well, wait a minute, 400 gigatons, 400 over 360,000, oh, that's a millimetre of sea level rise. 1 millimetre?
Unmeasurable.
Yeah, it is unmeasurable. So you're being treated like idiots. Yeah. People, and some of the people in the press have got no science behind them either, and they're making similar stupid statements. I'm very proud of this diagram. Hands up anyone here who's had a drink in the Regatta Hotel in Brisbane.
Oh, yes.
A few, not very many. Well, when my mother retired from Toowoomba, she lived in a unit near that hotel. And the Brisbane River flooded in 1841. When it did, the level was up to here, though the hotel wasn't there. But when the hotel flooded in 1893, water level was to there. And then more recent floods, which they said were unprecedented, 1974 was here, and 2010 was here. And they were saying these floods are unprecedented. But if you go to the pub, you can go up on the veranda and they've got the marks where those old floods were. And I used to go over there and have a beer, and my wife and I have had meals there. And if you ever go to Brisbane, it's worth a visit, because when people tell you about unprecedented things happening, go to that Regatta Hotel. Mm-hmm. Then, in terms of the recent weather that we're having, we've got two systems, one on the west of Australia and one on the east, that affect the temperature of the water along the coast. When we have a negative Indian Ocean dipole, we get all the warm water near the West Australian coast. When we have a positive, the warm water is near Africa. So when we do that, we've got all this warm, moist air near the northwest Australian coast. And if you look at these here, the statistical distribution of these Indian Ocean dipoles, there's nothing unusual. There's been no sudden dramatic change. It's random, but it's not. There's nothing there that's statistically saying they're getting worse and all that. And then if you look at these diagrams here, when we have warm water on the East Australian coast, which is a La Nina situation, so we've got warm water on both sides of the continent, we get these very wet years, and we've been having that because we've had a couple of La Ninas in a row. Then when we have the opposite, we've got the El Nino, the colder water temperatures here, colder on the other side, then we're liable to have drought conditions. So what's new? Australia's lived with that for centuries. And then there's another thing called the southern annular mode, which is where these westerlies are relative to the southern coast of Australia. That also affects moisture. So that's a smaller complement to the weather. But we've got all those three things affecting us. So we've got La Nina and El Nino cycles, positive and negative Indian dipoles. We've got southern annular modes. And that just gives us a normal history we've had for the last few hundred years of floods and droughts. And to say things have changed or unprecedented doesn't make any historical sense whatsoever. If you look at temperature changes over the last 30 or 40 years too, you can see that when we have a La Nina, we have a cooling, El Nino, a bit of a warming, and when we have volcanoes like El Chichon in South America or Pinatubo in the Philippines, with all that extra ash, we have a bit of a cooling. So there are some things modulating the temperature record that we have, which are more related to changes in ocean temperature or to volcanic ash in the atmosphere. Now I'm getting near the end now, but climate models are not predictive tools. They may show how some forces interact, but they can't make predictions of a non-linear system. And as I said before, they can't even handle cycles that we've had historically for years. They can't do that at all. As I'm saying here, they're as useless as chocolate teapots. Now, the first climate models, the Japanese who developed, he's a brilliant man. He's still alive. He's in his 90s at Princeton. Sakura Manabe, and his computer only had a few 100,000 K of RAM, and his program would take 30 to 60 days to run. And what he created was 60 degrees longitude of water, 60 degrees longitude of land, and he was playing with changes in the atmosphere. And then a man called Kirk Bryan joined him, and they added the ocean to that, and a guy called Weatherald. And they were the first computer, and it was good that they were making these models, but then people went overboard with them. And they are now, the grids have changed now, they're much more sophisticated, there's hundreds of thousands of them. But the grid size still, if you reduce the grid size too much, the computer model could take thousands, if not more, years to run. So there's a real limit to these models in the first place. My son, Dominic, grabbed a cartoon and played with it to show that all models have to be tuned, because even when they got a model, if it's not working, they keep tuning it to make it look right. So in other words, if you wind it up, watch me, because I can then predict the climate, but the whole thing's been tuned. And in my book, I go into how tuning has been going on for thousands of years. Even the Greeks tuned their models just to get the movements of the sun and the moon and that correct. Now finally, at the heart of the whole of climate science, there was a meeting in around 1979 of the US Academy of Science. And they tried to predict then what was happening, what are the key features in the models, and they determined the key features were carbon dioxide, water vapour, the amount of snow cover on the Earth, which is the reflectivity of the Earth, and the role of clouds. And they, at the time, they only had a few computer models. They had Manabe's models, and they had James Hansen's models. Now, James Hansen studied Venus, and he's been a catastrophist since day one. So they said, oh, well, this is in the too hard basket. We take Manabe. He said the sensitivity to doubling CO2 is 1.5 degrees. Hansen, 4 degrees. We'll give this a range. So we've got this equilibrium climate sensitivity index, which is a range of what could happen if carbon dioxide levels double. Now, believe it or not, things haven't changed much. I was a reviewer for the last IPCC 6th assessment report, and they've only changed it now. They've got worse. They decided clouds are a bit more on the negative side, so they've put the upper limit up to 5 degrees. So they've now got this wide range of changes that could happen if the CO2 doubles. And it's really weird that after all these years, this is the best that climate models can do, but it just shows actually the limitation of computer models. So if we finish up now and look at some of the models, now this is, believe it or not, the sea surface temperatures. Now around 2000 they decided they would put these buoys in the water. The buoy would go down to 2,000 metres, record temperatures, go back up, then transmit to America the data, and they've now got about 4,000 of these travelling all around, giving us incredible data, which we never had before. And here is the actual ocean temperature. It's been going up a bit, but this is what the models predicted. The models are all on steroids. They're out to blazes. And then, sorry, if you look at this one, every day balloons go up and take temperature all around the world, and we've also got NASA satellites taking temperature, mainly, it's a bit more complicated, but looking at oxygen in the atmosphere. Now the balloon data and the satellite data are in good agreement, but look what's happened to the IPCC models up to 2020. They're all on steroids. So we're being run by models that are on steroids. And that is one of the tragedies of modern climate science. It's we're being wrecked by models, and people who live for their models and love their models. And to finish up, this is an interesting graph. The NASA temperature data is taken at the University of Huntsville, Arizona. This is Australian temperatures over the last decade and a bit. We've gone nowhere. That's the satellite average. Nowhere. There's been no linear warming trend in Australia over the last decade at all. So to finish up, all of these beach cycles are around. They are much more complicated than people have given them credit for, and a lot of the changes in our shoreline are not due to sea level rise, but to complex dynamic beach processes. There is sea level rise. We have been warming a bit, glaciers have been retreating, but there's no acceleration in that sea level rise. Carbon dioxide and temperature do not dance together. We can't make carbon dioxide the knob which controls historic temperatures. It hasn't worked in the past, it won't work now. We know the storms aren't getting worse, they're getting a bit milder. And our present Australian weather is not unprecedented. It only becomes unprecedented if we take time zones that are far too short. If we want to look at historical comparisons, we've got to look at least a couple of hundred years.
Well, there's deliberate time frame cherry picking going on.
Oh yeah.
Deliberate.
That's right. And the models are on steroids, and our reliance on models is misplaced. It's not a time to panic. So that's the summary of what I've got to say tonight. I'm happy to take any questions. Thank you.
Questions from the floor, but let me just maybe add a comment, maybe not so much a question. As some will know, I've been on the water around Sydney Harbour for just on 50 years. Originally as an oarsman at nearby Ionosphere Rowing Club, and nowadays as a sailor. I've been racing a high-speed catamaran. I'm on my third one, right? I think I'll be buying a fourth in the upper reaches of Sydney Harbour. I'm a member of the board at the Concord and Ride Sailing Club. Used to be a member at the Rowing Club as well. I'm on the board there. And for the life of me, Howard, I've seen the water rise up and go down with tides. I've raced in it rowing-wise. I've raced up. Paul Gurr here with me from the Sailing Club is a regular sailor. I cannot detect any movement whatsoever in the sea level rise that's affected by the Pacific Ocean. It comes up as far as Parramatta and it goes back out again every 6 hours of the day. And for the life of me, I cannot.
I agree with you.
Any change.
I've got a friend who's surfed in or swum in Balmoral Beach for years, and he still goes out to the same rock, and he says it's around the same spot.
We're faced with this.
But any change, even what I said before, those beach movements, they could hide a sea level change of a few centimetres, but you wouldn't notice it.
You can't notice it.
It's beyond
the average passerby and the average enthusiast of the waters.
Yeah.
You cannot. It is imperceptible.
Yeah.
However, we have a question from the
Sorry,
backbenchers. Peter.
Indeed, sir. Well, I'm sure we've all seen estimates of the official amount of sea level rise, probably between 1.5 millimetres and 3.4 millimetres, and a great deal larger. Is there any accurate figure that we can use ourselves to consider what the actual annual rate of sea level rise?
If you go to Liverpool, that 3.3 is all from satellites. It's not from tide gauges at all.
So what's the tide gauge?
The tide gauge is around 11 to 13 centimetres over 100 years, which is over the last 50 years, 3 or 4 centimetres. So, and you've got to realise that the ocean is not the same everywhere. So there could be slightly more rise someplace than another due to winds and all that. But the only place to go to is the Liverpool data. Just ignore the satellite data. All that 33 stuff, none of that's out of Liverpool. And the other danger is that if you go to places where there's sinking, like Hong Kong or Bangladesh, you'll get an exaggerated rise in sea level. If you go to places like Scandinavia, where since the last ice age it's still going up a bit, you won't get any sea level change at all. So you've got to be careful as to what place you're looking at and the reasons, etc.
Okay.
I
Sir?
think in Juneau, it's about 15 millimetres a year down.
When I was at school, we went to Pinchgut on an excursion, and there's a flight of stone steps which fronted the Opera House. And on those stone steps was the tide gauge. And when I was there, a man came along with a book and a pen. And I was told that at midday, every day, they'd taken readings from that time gauge for like 100 years.
Mm.
In fact, there was 2 tide gauges there. One of them had rusted and almost fallen off the wall. So they put a new one. Now that's 50 years ago.
Yeah.
So as far as accuracy of tide in Sydney Harbour goes, I don't think it's much better.
Yeah, the Tasman Sea's seen very little. I think there's some places have seen a bit more, but we're certainly in a pretty dead area.
Yeah.
Sorry, sir.
Sorry, I'm David.
Yeah.
Do any of these cycles have anything to do with the Earth's position in its orbit around the Sun as it processes?
It's a bit more complicated than that. The long time, ice ages and that are more related to changes in the ellipse of the Sun and angles to the Sun. But you've also got changes where the Earth's position will wobble a bit and the Sun's position will wobble due to the position of the planets. And they're all called the petrichoid cycles. Some people used to laugh at them, but they're not. And they are there also. That's in my book. But they're very slight cycles, but some of them look like 180 years, and they're very slight. There's also another sort of cycle. The Russians have got instruments on the International Space Station looking at the radius of the Sun. The Sun doesn't have a constant radius. It oscillates. When it gets bigger, the surface area or the heat from a sphere depends on its surface area, which is 4 pi squared. So increase the surface area of the Sun, it'll give out a bit more heat, contract it a bit less. There are a lot of little changes like that going on that are totally ignored by the IPCC because it's only totally involved in the Earth and humans. So I hope that helps a bit. Yes?
I know right back in the 60s when I was in high school in geomorphology, we were taught this very basic concept that coastlines over time try to straighten themselves out. So embayments prograde, move forward, and headlands erode, and they straighten. So all that progradation that you show is a natural process.
Yeah, well...
And that Brun Model, whatever it's called, they don't take into account sediment transport, do
No,
they?
the Brun Model works on forces being at right angles to a beach,
Yeah.
which is totally erroneous, because some beaches the currents can shift the sand from one beach to the next one up and vice versa. So there's a lot more dynamic process going on in beaches.
And that model ignores them completely. It's
Oh, yeah.
just too simplistic.
That's right.
And the other thing too, of course, is that those model-dependent sea level rise scenarios are based on essentially impossible carbon dioxide emissions quantities.
Yeah.
It just won't.
I know.
By 2100, it's impossible to get the CO2 that high.
Yeah.
So they're just nonsense.
Yeah. So, call the day.
Could I ask a question?
Please go ahead.
John Booth,
I don't know
editor
if I
of
which way I should face
Tidal,
so everyone can hear the question.
the Weekly Times.
Some little while ago, I was at the Sydney Opera House where a fellow that you've probably heard about, he called himself Professor Flummery or Flannery or something. We were paying him $180,000 a year as a part-time job to do a big report and investigation. I happen to be one of the few journalists who turned up for his final presentation of reports at the Sydney Opera House. I asked him, I said, Professor, you say that the water's going to rise, substantially over the next 50 years. Can you give me an estimation exactly how high it will rise in the next 50 years? And we were on the harbour side of the Opera House where the presentation took place. and there's some steps, if you ever get out there, there's some steps running down. And there was a seagull on the third step up. And I said, Professor, in 50 years, how high is it going to rise? Would it be about that first step, the second step, the third step, fourth step? He said, oh, well, yes, one of your famous, yes. He said, it'd be about where the seagull is. Now that was in 50 years, it was going to be that high. And I said, I have another question for you. Do you know that little island over there? Some people call it Pinchgut, some people call it Fort Denison.
Yes.
They actually have been keeping records for 150 years there of tides. I've been there, and it shows there's been no change in 150 years. How is it going to suddenly change in the next 50 years? Oh, right, he turns around. How do you answer a bloke like that? He's got the cheek to come out again recently, a couple of days ago on television, sprouting a bit of a whiskers and stuff, making him look different. They made him Australian of the Year. I think he should be Australian Joker of the Year. Be fair enough, but he came out, he's professing again about something similar. How do you answer a person like that?
You can't. Sorry. Go.
Arthur?
If you just draw a straight line, trend line through that sea level record, right, you get 85 millimetres of sea level rise in hundreds, quite low because of various factors. But if you look at it more closely, you'll find that there's a 50-year hiatus in sea level rise for the whole of Eastern Australia and right across Australia, right across to Fremantle. There's a 50-year hiatus in sea level rise between 1950 and 2000 and starting upping, and that is related to weather. It's related to the things that Howard was talking about and high pressure systems changing latitude, because that weight of that extra air pushes the sea down. Air pressure is a big impact on sea level. If you change the long-term average sea air level, air pressure, you will change the sea level, and you can actually see that in that data set if you look closely, the one you were talking about. You'll see a 50-year hiatus.
You'll also see
It's reproducible.
when there's a La Nina event and the water comes over to Australia, and then there's a El Nino and the water goes to South America, in those mid-Pacific islands there is a change of sea level of about 30 centimetres.
30 centimetres, yeah.
And that happens during all those cycles, and they've lived with that for years.
And you can see that in all the tide gauges. If you go and download the data, plot it up in Excel, there it is.
Yeah.
Big, heavy, massive high pressure sitting on top of thousands of square kilometres of ocean, pushes it down.
Pushes it down. It's amazing.
Right? That's what you're up against when you're trying to measure global sea level.
Yeah, I know. Good. Sir?
Howard, I read somewhere that the IPCC climate models, that they run too hot.
Yes.
But there is I also read there is a Russian model which is probably the best simulation to what has actually happened historically. Is that the case?
Yeah, one of the Russian models is one of the best. And the Russian model takes into account, those cycles in the ocean that I mentioned, the Pacific Decadal Oscillation and the Atlantic Meridional Circulation. The Russians have all those oceanic things in there, and that's from the Pulkova Observatory in St. Petersburg. Yeah, that is one of the best models, that's for sure. And if you look at all those models that Professor Spencer did, showing they're way down near the balloons and the satellite data. Yeah, the Russians have been there.
You mentioned Professor Spencer. Is he the man from
Huntsville.
University of Alabama?
Yeah.
Huntsville.
Yeah, I'm in a group with him also out of Princeton, and there's two of them, Professor Christie and Professor Spencer. Yeah.
John Christie.
Yeah. Sir?
Look, there's something I've never quite understood about the physics of greenhouse gases, so maybe I should ask now. So I understand that the frequency bandwidth of absorption for any greenhouse gas is a natural limiting factor on how much long-wave infrared radiation it can absorb and immediately re-radiate.
That's right.
And things like methane have two very narrow bands. CO2 has a much wider band.
No.
But I've never really understood, therefore, how things with very narrow bands, like methane or nitrous oxide, have a much higher warming effect, therefore reflect much more long-wave infrared radiation back towards the ground.
They can't, because in the laboratory, as I said, if you compare them, they can be stronger. But in nature, they're competing with water vapour.
Well, yes, water vapour saturates, but even in a lab, as their
No.
ability to absorb is limited by their bandwidth.
Yeah, they're still strong.
And that's my question. How is it stronger? What's making it strong?
Well, there's nothing to compete against. So, say in the case of carbon dioxide, anything between 14 and 16 microns, it's going to be absorbing
Yes,
quite strongly.
But that's its full bandwidth.
No, it's got another one around 4 and a bit. It's got only 2.
Is it due to its concentration in the atmosphere being so low that its overall effect is much less?
Well, in the lab, they're looking at 100% carbon dioxide, but it's still, the wavelength that it's going to be absorbing doesn't change.
No.
Yeah, that's what I've never understood. if the wavelength is the limiting factor, and you've got no saturation from
No.
No, yeah.
You're wrong there, because in nature you've got like, I think it's about 25 water vapour molecules per 1 carbon dioxide,
Yes.
right? But if you do it in the lab, you won't be having that at all. You're going to have a lot more carbon dioxide. So the ratio is going to be
So
different.
what you're saying is their claim is based entirely on lab experiments where there is no water vapour in the atmosphere.
Yeah,
So
absolutely.
therefore, methane, nitrous oxide,
Yeah,
2 examples, does not in fact have a much greater warming effect than carbon dioxide.
In nature.
not in nature,
Not
no,
in nature.
because they're limited. They're fighting with, in nature, I said there's 1 methane molecule to 3,000 water vapour molecules.
That I understood, but that's due to saturation by water vapour.
Yeah,
Yeah, but the water vapour is not evenly distributed. I mean, there's something in the order of a 20-odd-fold change in water vapour in the lower troposphere.
well, most of that's going to happen in the lower 4,000 metres anyhow, but
Yeah.
there are places where there's deserts where there won't be much water vapour, or the poles. But the figures I gave you was to try to look at New Zealand, which had a high relative humidity, and the Netherlands. So to think that methane, those are going to be doing any damage in those areas is crazy.
Well, I'm looking at the data, I've never thought it could, but
No. Yeah,
It depends on the assumptions you make about the amount of water vapour.
Yeah.
And the
that's right.
the saturation effect from that. And what they've done with the methane is over time they have deliberately gained those assumptions to amplify the effect of the methane, to maximise it out by fiddling around with the assumptions about the water vapour. Because it's so variable and so abundant. So
Just
Sorry.
focus
Don't they
on,
say it's the feedbacks that are the killer?
oh, well, then there's feedbacks on top of all that.
Young lady
can't-
at the front.
this focus on methane, is that just trying to force mass starvation? Is that what this is about? I mean,
No, they actually,
conspiracy theory.
they actually believe it, because they also looking at the fact there's a lot of methane in the polar regions, hidden in the ground or under the ocean, and they're saying if that could be released, it's a disaster.
Right.
So that's in my book too. But again, you can't heat the ocean enough to release the methane that's in the ocean floor, because the bottom of the ocean is about 4 degrees. You won't be able to heat. You can't. It take thousands and thousands of years to do it, and then you wonder how you do it.
Yeah.
And then on the land, like in Siberia, there are places where methane's being expelled, but the amount is peanuts.